Sorry I can't be here today, guys. So instead of being here, the next best thing, you get to listen to me teach you through video. Ooh. All right, so today we're gonna do 3.3 notes, 3.4 and 4.1. I think we can get through all of it. This is just modeling through through drawings again. This is algorithms. We've already done this. We're just gonna do a little bit of practice. We'll come up with an algorithm for all of our dividing and multiplying and using fractions. And then we'll do fact families and then some homework time. Fact families, most of you guys already know that. You just don't know that you know that. Okay, so we are working on 3.3, 3.4, and 4.1. Please note they are on different pages. Okay, this is one of the few times I will list them on different pages. It's because they are on different investigations. We do investigation 3 and investigation 4, and they aren't well connected, at least not these two. So we're going to do 3.3 and 3.4 on page 19 and 4.1 on page 20, both of them today. Oh yeah, pause if you need to, so you can copy this down to your notebook. Cool. All right, 3.3 and 3.4, dividing fractions by a whole number. We did whole numbers divided by fractions already, so now we're going to do fractions divided by whole numbers, the other way around. And then we're going to do algorithms for dividing fractions. So what does dividing by a whole number look like, and what algorithm can we use for dividing fractions? There's a YouTube link here I'll play for you guys in a little bit. I'll just play it within this video. We're going to answer 3.3, page 52, A, B, and D, and they are on this printout for you guys, and I'll show you how to do it. I'll let the sub give you some time so you can work on your own, and then she'll play it so you can see what it looks like. Okay.
Of lemonade to sell at their lemonade stand. They divided the lemonade equally among 4 paper cups. How much lemonade was in each paper cup? First thing we want to do is try to figure out what this problem is asking us. What is our dividend? What is our divisor? Well, if we go through this, we see that he has 1/2 of a gallon of lemonade, and he wants to divide it equally among 4 paper cups. So if we were to write this as an equation, that would be 1/2 for 1/2 gallon divided by 4 cups. We're trying to figure out how much lemonade was in each paper cup. So one way we can do that is to draw a model.
Okay, so he's drawing a model of a gallon, a half gallon here. So this is going to represent his gallon. He's going to fill in half of it with lemonade.
So of our whole, I'm going to shade in 1/2. It's going to represent 1/2 of a gallon. Now we're seeing that they're going to divide the lemonade equally into 4 paper cups. So let's take our whole and divide it equally into 4.
So that represents each cup.
2, 3, 4. Now I want to figure out how much lemonade was in each paper cup. So let's see how many parts are shaded. We have 1, 2, 3, 4, which tells us that we've successfully divided our half gallon into 4 groups. For each group, we have just 1. That tells us our numerator. And how many total parts do we have? We have 1. Let's show that in
Okay,
red.
so this number here, this 1, his numerator represents how much is in 1 cup. So that's how much is in 1 single cup. And his total parts here, which is 8, represents how much of a gallon is in each cup. So 1 cup over total parts. Okay, over total parts. So it's very, very important that you have a 1 whole to start with whenever you are dividing a fraction by a whole number. Okay, so let's let him finish.
We have 1, 2, 3, 4, 5, 6, 7, 8, we have 8. So now we see that if we have a half gallon, we divide it among 4 cups. Each cup is going to have just 1/8 of a gallon. In this lesson, you will learn how to divide.
So 1/8 of a gallon, that's actually a lot of lemonade. Those are big cups. All right, so back to our lesson. That's an example. You don't have to write it down. Let's go see what it looks like in our questions. So Miss Lee gave peanuts as prizes for a relay race. The members of the winning team share the peanuts equally among themselves. What fraction of a pound of peanuts does each team member get in each situation? Okay, so let's just draw some of these peanut pounds. So this is going to represent my 1 pound of peanuts. So here's my 1 pound of peanuts for question number 1. It says the students share a half pound of peanuts. Okay, so I'll cut this in half. So I'm going to do 1/2 divided by 4 students. So we just did this one in our gallon exercise. So it should look like this. I know that I have this many peanuts, and I'm going to divide it into 4 parts. So I'm going to say 1/2 divided by 4. I'll do this in a different color because that's a different idea. So here's my 4 cups. 1, 2, 3, 4. Or 4 pounds, sorry, not cups. So we know we're going to end up with 1/8. Our solution should be one of them. I don't like that color. Let's do this one. This is our solution here. We just want 1, which equals 1 out of the total number. And the total number comes out to, let's find a new color, 1, 2, 3, 4, 5, 6, 7, 8. 1 out of 8. Okay, they get 1/8 of a pound each. Okay, I'll do that again for number 2. It says 3 students. Actually, you know what? The sub can pause the video here. You guys can work through this. Please model question A. You do not have to model question B. You can just solve it, but if you like modeling it, that's fine as well. And then describe a strategy for dividing fractions by a whole number. Refer back to the previous lessons for the definition of algorithm if you don't remember. If you do remember, great, you don't have to turn back. I think it's in 1.4, but it's not in investigation 3, so it's probably in investigation 1 or 2. It's kind of far back. So go ahead and work through this. Pause the video. It should take you guys maybe 10 minutes, maybe a little bit more, 10 to 15 minutes. And then I'll do the rest of the work, and then the sub can unpause it and you guys can check your work. Okay, so question number 2 says 3 students share a 1/4 pound of peanuts. Okay, so I'm gonna make this a little easier on myself. I'm gonna make sure that this square lines up with my line, so it's easier to divide. Okay, so they have a 1/4 pound of peanuts. Okay, so here's my 1/4 pound. 1, 2, 3, 4. Wow, those are not very good. Let's fix that. That's better. Okay, so they have a 1/4 pound of peanuts, and they have this many peanuts. Okay, and then they share 3 of them among 3 students. So 1, 2, 3, beautiful lines. And my question shows up as 1/4 divided by 3 students, and that should equal, well, let's find out. That equals 1 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1/12. Good. All right, let's get these out of the way because they're starting to crowd my space. Okay. And we'll do question 3 and 4. So here's question 3. And we'll do question 4 over here. I'll just write my equations as we go along. All right, so question 3 says 2 students share 3/4 pounds of peanuts. Okay, so I'll divide this into quarters. Oh, you know what? I did that the wrong way because I did it the other way first. So let's divide it this way. 1, 2, 3, 4. Okay, and 2 students share it. So when my students share that, I will cut it in half this way. 1 for the top student, 1 for the bottom student. Okay, so they shared 3/4 of a pound. So 1, 2, 3/4 of a pound. So that's 3/4 divided by 2 students, and that equals, well, one part represents 1. My mistake, not 3, not 1, but 3, because 3 is our numerator over here. This is what I'm getting at. Before I had 1 and 1. Here I'm looking for my numerator 3. So 1, 2, 3 out of a total of 8. So 3 out of a total of 8 possible. 1, 2, 3, 4, 5, 6, 7, 8. 3 out of 8. 3/8. All right, next one. 4 students share 1.5 pounds. Okay, so I have to make actually 2 of these because I have to make a whole. Okay, so 1.5 pounds. So I'll cut this in half, and actually I'll cut this one in half, and I'll cut the other one in half just so I have equal parts. It's a lot easier to see in equal parts. So we have 1.5, 1 there, and a half there. Good. All right, I'm gonna split this into 4 students. So 1, 2, 3, 4. So there's 1 student, 2 students, 3 students, 4, and same thing here. 1, 2, 3, 4. Okay, so our equation is 1.5 pounds. 1.5 pounds. So I'll make that into a mixed number. 2 times 1 is 2 plus 1 is 3. 3/2 divided by 4. I have 3 halves. 1 half, 2 halves, 3 halves. So I need to figure out. So what I'm originally looking for now is how much one of them will get. One of the 4 students. So 1 student, this represents 1 student, 2 students, 3 students, and then 4 students. 1 student receives this part. 1 student gets this one, and this one. So 1 student will receive 3 parts out of the total of however many are in one whole. Again, this is out of a whole. So 1 student will get 3 parts out of one whole, which represents 8. Okay, so this top portion is how much one person gets out of the number of parts in a whole. Okay, so the denominator is always parts of a whole. Okay, part B, find the quotient and explain how you thought about it. Most of you guys will probably remember your algorithm that we did before. Keep it, switch it, flip it. So 2/3, and then divide by 5/1. I'll keep it. 2/3 times 1/5, and then multiply 2/15. That's question 1. Question 2 is going to be 3/2 divided by 2/1. Keep it. 3/2, switch it, times, flip it, 1/2, and we get 3/4. Number 3 is going to be the same thing, and 4, 2/5 divided by 3/1. I'll pause it and then I'll just finish out the questions. You can check it. Okay, so for this last one, when I flipped it, I made a mistake. That should be over 4. So when I flipped it, times 1/4. The nice thing is these cancel. and I end up with 1/5. Okay, there's the answer for 3, which is 2/15. Again, whenever you can, reduce it. So describe a strategy for dividing fractions by a whole number. We've talked about this before, and we can kind of use the same idea. So our algorithm will be 1, keep it, 2, switch it, 3, flip it. Okay, we can stick with that. That works. And sometimes, maybe like a step 0, let me put it up here. Sometimes it depends on if you need to do this or not. You might need to, what's going on here? Step 0, you might need to change to a improper fraction. Okay. I don't know what's going on there, but it works. Okay, so keep it, switch it, flip it, change to improper fraction. Awesome. Okay. You can go to the next page. I cross out some things because you don't need to estimate. I'll post the answers and you can check to see if you got it right. Again, you're probably 12 questions, some simple division, maybe 15 minutes or so. Okay, and then subcomposite and play it again so you can check your answers. Write an algorithm for division involving any two fractions. We did that the last time, but I'll put it here again. And then use your division algorithm to divide. So I'll put those in here as well. So let's go ahead and pause the video. You'll work for about 15-20 minutes or so, and then you can check your answers. Okay, so here are the answers for question A. Go ahead and pause it just to check to make sure you got it right. For question D, I did the same thing we did in the last one for the algorithms. Any two fractions, keep it, switch it, flip it, but make sure you change it to an improper fraction if you need to. And then part E, your answers are right down here. I'm going to put it right here so it's not so far away. You kind of see them all together. Pause it if necessary, and then I'll go on to 4.1. Okay, so 4.1 is fact families. Again, you should have this one with you as a printout at least. So an addition sentence, for example, 2 plus 3 is 5. You can change them into other sentences. 3 plus 2 is 5. 5 minus 3 is 2, and 5 minus 2 is 3. Okay, and they did this similar example, but they just changed all the values of 3. Okay, you'll notice is that every value of 3, they changed each one with the value of n. So n was 3, 3, 3, and 3. We know that because that's a very simple math equation. 5 minus something is 2. That's got to be a 3. 5 minus 2 is 3. So these are fact families. It's one equation written in its different forms with its opposite operation, from addition to subtraction. Okay. Now that still holds true for fractions. We can do the same thing. 3/4 plus 1/8 is 7/8. And then you can notice that these same 3 items can be moved around with another addition and then 2 subtractions. And if you had a variable, it'd be the same thing. 6/8 plus something. And actually these numbers here both represent 1/8. They just change the 3/4 to 6/8, so that way you'd have a common denominator across the two. So we know that something has to be an 1/8 to get there. Okay, so fact families, addition and subtraction. How do fact families help you solve equations with variables? Okay, so fact families are very, very important. A lot of, like I said earlier in the video, a lot of you guys already know what fact families are. You just don't know that you know. So they're gonna help solve equations. Very, very important. Okay, and most importantly with variables. Okay, so we're gonna help solve equations. So for question A, and this starts in 4.1. Let me get you the page number in just a second. Okay, so it's on question start on page 67. There's only 2 questions, A and B. The questions are in your book, are in your notes, sorry. They're also in the textbook on your desk. So if you don't have a textbook, you can just use your notes sheet. For each number sentence, write a complete fact family and find the value of n. So what I did was I just made a copy of this. I put them down here. There's question A1, A2. Okay, so go ahead and work on this. Fill this first question out in question A1. This one is A2, can go in here, and you can write the related number sentences. Okay. For part B, for each number sentence, find the value of n, write a fact family statement. Okay, this is your statements down here. Okay, these are your related number sentences. So for each number sentence, find the value of n. What I want you to do is write the equation like this one, the one where the n is equal to at the end. Okay, the one with the variable at the end. You want to find your fact families so you end up with this one. Okay, so you can solve for the variable. That way your variable has an equal sign right next to it. Okay, so that's what you're looking for. Okay, go ahead and work on this. I'll put the answers up in just a second. Okay, go ahead and pause the video and we'll come back to it. Okay, so the original question, 5 over 10 minus 2 over 5. There it is. And then here are the fact family statements. 5 over 10 minus n equals 2/5. 2/5 plus n equals 5 over 10. And n plus 2/5 equals 5 over 10. This is the one that we want to use, okay, to solve. Same thing for this one, question 2. What they did is when they rewrote it with a more common denominator, which is 15. Strangely enough, I don't know why they picked 15. These are your different equations. You can rewrite it with 1 2/3 plus 3 3/5 equals n, n minus 1 2/3, etc. These are your rearranging of the answers. Okay, this one ends up being n equals, let's see, what do we get? 5/10, and I can make this into 4/10. So 5/10 minus 4/10 equals 1/10. So for question A1, we get 1/10, and then for question A2, we'll make this times 3 times 3. So 3 and 3 and 9/15 plus 1 and 4/15 equals 4 and 13/15 for A2. Part B, for each question, write a number sentence. So here are my different number sentences. They're rearranged so that it's n equals something. So they rewrote this so that it's equal to n. So instead of it being an addition, it becomes subtraction. N equals 4 1/6. And number 2, n equals 17/12 minus 3/4. Again, they just rearranged this. So they subtracted 3/4 and moved to this side. So n equals that. N equals 2/3. I know it says 8/12, but again, if you can reduce it, you want this one more correct than this one. And then 3 is n equals 3/8 plus 1/2, so n equals 7/8. So it says, how can fact families help you find the value of n? So fact families can help you find a fact in the family that expresses n as the sum or difference of the two known numbers. So this is equal, either the sum or the difference of two numbers instead of having to solve it. Okay. All right. Your homework, you have a copy of that as well. It comes out. You saw it on the first page, but this is what it looks like. Okay. So on the very first page, it looks like this: ACE 3, Investigation 3, 49 to 58, and Let's Be Rational, Investigation 4, 1 through 13, and it looks like this. Okay, so it's this sheet here. Okay, so front, and then there's the back. Pretty easy stuff. Go ahead and work on this quietly, and when you're all, if you finish before you leave, you can put it into your period 5 box. If not, just take it home with you, bring it back. Your name goes on this side. A lot of you guys are forgetting your names, but it's been getting a lot better. Okay. I'll see you guys Tuesday, and be good.